Hi.
Hello.
Hi.
Can anyone here benefit from saving on their heating, electric, or water bills?
Yes.
Most of us can. And if you could do it in an environmentally friendly way, would it interest you more?
Yeah.
Today we will discuss how sustainable architecture can benefit economic and ecological applications. The main points I'm going to discuss are sustainable energy and sustainable building materials and how they conserve energy and minimize the negative impact a building has on the environment. Let us start by discussing what materials these buildings are made of. Sustainable architecture often involves the use of recycled or salvaged building materials. Reusing saves energy and reduces emissions by lowering the need to manufacture new ones. Often, sustainable architects attempt to retrofit old structures to serve new needs. When old buildings are demolished, however, anything that's good can be reclaimed and reused. Many parts that are reused are doors, windows, mantles, and hardware. When these are used, they reduce the consumption of new goods. The next type of material I will discuss are low impact and natural materials. Ways of achieving sustainability by using these materials focus on the durability and the use of minimally processed and plentiful resources. Common natural materials include clay, sand, earth, wood, and stone. The last type of sustainable material I will discuss are renewable materials. People seem to think that timber is the only renewable building material, but there are many more. Many others, including bamboo, thatch, tar, and rubber. What makes these materials renewable are the fact that they come from living plants and animals and not from mineral or fossil deposits such as oil, gas, and coal. Now that we know the different materials that can be used, let's discuss the different techniques used to reduce the energy needs and increase generation and storage of energy. The first sustainable element I will discuss is an efficient heating, ventilation, and cooling system, otherwise known as HVAC. The more efficient a building is, the less heat needs to be produced, which means the less power is used. Ventilation systems keep pollutants from building up in your house. Operable windows allow for natural and wind-driven ventilation and require no energy. The next element in an energy-efficient house is insulation. Insulation begins working from the time it is installed and lasts the lifetime of the building. And unless it is damaged, it requires no further maintenance. For every BTU consumed in the production of insulation, 12 BTUs are saved in the United States by using it. Insulation reduces the average heating and cooling costs by around 20% according to the National Association of Home Builders. The next element I will discuss are passive and active heating systems. A passive solar house does not use mechanical means to store its energies. Placement of the house so that the southern face can receive sun means that natural processes can help keep things warm and cool. Passive solar building designs use materials with high thermal mass such as stone, concrete, brick, and tile that retain heat efficiency. In warmer climates where cooling is a primary concern, they are also effective because they retain the cool temperatures. Buildings are often designed to capture and channel existing winds, which aid in the cooling effect. Classic examples of these buildings are greenhouses and sunrooms. An active solar heating building uses mechanical and electrical equipment to turn solar power to electricity. Now let's look at the different ways of generating clean and energy efficient energy. Renewable energy is energy that's naturally replenished. Solar panels help to provide sustainable electricity. The output of these panels is dependent on their orientation, the latitude, and climate. Typical efficiency for these panels range from 4 to 28%. Another option is wind power. Wind turbines collect kinetic energy when the wind blows and is converted into electricity from this. A wind turbine can lower your power bill from around 50 to 90%, and because of federal regulations that require utility companies to hook up to your wind system, you can end up selling your excess power. The last form of renewable energy I will discuss is geothermal. The process involves trapping heat underground. The building energy then rises near the surface in the form of heat, which turns a turbine and turns that into electricity. The efficiency for these can be in the range of 92 to 94%, which means for every dollar you spend on energy, you get 92 to 94 cents worth back in return. In closing, integrated systems increase in efficiency when sited to work with nature and properly insulated. Conventional systems, heating systems, are more than 100% efficiency when used with renewable energy. When I began, some of you showed interest in how sustainable architecture could be